Okay, I think everyone who's coming is here. Thank you all for attending this little session. Today I'm going to talk about the stack effect, describe what it is and how it affects every HVAC design. And we will discuss ways that you need to take that into account and how to maybe change the way you look at things as far as quoting jobs in order to combat it from what we've been doing. So my name is Rick Cummins. I am a regional high efficiency product specialist at Gensco Regional, in that I cover Western Washington State and the state of Alaska. I'm one of 4 Mitsubishi outside sales DSGs. We have Chris Stein, who has accompanied us here in the webinar, is covering our mountain area, Montana, Idaho, and Eastern Washington, some of Wyoming and northern Utah. We have David Wood down in Oregon, out of the Portland area, covers the state of Oregon. And Jonathan Nordenson, who assists in the Western Washington area. So a typical house, there are 3 main forces that drive airflow, air movement within a home. Number 1, of course, is your HVAC equipment. Number 2, and surprisingly, not many people take this into account either, the wind. On a very windy day, we could have increased infiltration due to the pressure differences that are created from the windward side to the leeward side of a home. And the thing that we're going to talk about today, the stack effect, also known as the chimney effect. So what is it and how will it affect your homeowner's comfort? I bet a lot of you actually live in a 2-story house or a multi-level house. Everyone knows that heat rises. Does it really rise? Actually, not according to the laws of thermodynamics. Heat moves in every direction. It moves from areas of higher heat content to areas of lower heat content. What does rise in the home is heated air. And this is due to 2 physical laws. 1, Charles' law, and 2, Archimedes' principle. French scientist Jacques Charles is credited with the discovery that when a gas is heated, it expands. And that's the key word, it expands. Greek mathematician and all-around super guy, physicist, engineer, astronomer, inventor, Archimedes is credited with the discovery of buoyancy in a fluid. And while we think of fluids as water or something like that, air is also a fluid, it's just very thin. These 2 laws are going to greatly apply to air movement within a home or building. As the air in the home is heated, it expands, becoming less dense than the air around it, and it begins to rise, think hot air balloon, to the upper levels of the home or the room or a building until it meets something that stops it from rising, that being the ceiling. At this point, an interesting phenomenon develops. The movement of the air builds pressure in the direction of its movement, the upper ceiling. In winter, the pressure builds at the upper levels of the structure, and in summer at the lower levels of the structure. And this is what leads to comfort and home performance issues. And anyone who's ever lived in a 2-story house knows it is always warmer upstairs than it is downstairs. And that's where the stack effect comes in. The temperature differences between the outside of the house and the inside of the house cause air movement from the lower level to the upper level. This can actually be measured using this formula. If this home had a 70-degree internal temperature and a 32-degree external temperature, and a height difference from the upper ceiling to the lower floor of 28 feet, we could expect to see a 0.0313 inches of water column pressure differential between those 2. Now that in itself is interesting, but what it's going to cause, indicated by these arrows, is infiltration and exfiltration. In winter, the outdoor air being colder, pressure builds at the top. And once there's a pressure difference between the inside of the home and the outside, we're going to go to another scientist who's really famous, and we deal with his discoveries every day, Daniel Bernoulli, a scientist and mathematician who derived Bernoulli's principle. Pressure flows from areas of higher pressure to areas of lower pressure, provided there is a pathway for it to flow. And the amount of that flow depends on the size of the pathway and the level of pressure differential. And we use Bernoulli's principle in designing ductwork. It is the basis of the ductulator. When the pressure differential between the indoor of the home and the outside, the air will begin to move through any openings between the inside and outside. We call this exfiltration. And you've all heard the expression, probably, nature abhors a vacuum. We cannot exfiltrate without also infiltrating to make up that loss. And this is what's going to drive a lot of heating problems. So the greater the pressure differential, the greater movement of air. In the summer, this flow gets reversed. In Western Washington, it's not a big deal because our indoor and outdoor temperatures are not that drastic. It would be a lot bigger of an issue if you lived in the South, Arizona, Texas, the Gulf Coast. Air will begin to infiltrate in heating at the bottom of the at the bottom of the home in summer and infiltrate in the upper portion of the home. But no matter what season we're in, the main point is that the air at the top of the structure will always be warmer than the air at the bottom of the structure. And you've probably all had to deal with homeowner complaints around this. So how's this going to affect your design? In the winter, which is our main driver here on the West Coast, in the winter, all the infiltration into the home will be in the lower levels. There will be no infiltration in the upper levels. All the air that is heated by the HVAC system will rise up to the top of the structure. All the internal heating from the people, appliances, and plug loads will also rise to the top of the structure. Therefore, there will be a much reduced need for actual HVAC heating on the upper level of the structure. And I'm going to illustrate this phenomenon with an actual case study that proves this point. I took a complaint from a customer of a homeowner's complaint of overheating in the master bedroom, drastic overheating. Is there a problem with the unit, which the contractor was chasing, futilely chasing, I should say. This was a photo, rather blurry, I'm sorry, of her thermostat, an MHK1 wireless Mitsubishi Stat at 4:15 a.m., showing a room temp of 78 degrees with a set point of 64 degrees. Now, this alone would make me think, geez, it's really overheating. The HVAC equipment consisted of a ported multi-zone 5C42 with wall-mounted units, GL18 serving the downstairs area, a GL15 in the upstairs great room, and an MSZ GL12 in the upstairs master bedroom, the problem room. The homeowner granted me a request to install and monitor this system using some data loggers so I could see what was actually going on, along with connecting our M&P maintenance tool to the outdoor unit. I wanted to be able to tie all the actual temperature readings within the home to what the unit was actually doing. And this was done a week of April 12th through 16th, 2 years ago, 2021. And the site was located near Gig Harbor. A current data logger was connected to the S1 wire of the bedroom MSCGL12 so that I could see when the fan was running and what speed it was running at, and compare this to maintenance tool data. I set this to record an amp reading every 10 seconds. A temperature and humidity data logger was set on the top of the unit for return air and in the outlet louver to record supply air and return air temp every 30 seconds. And the reason I wanted to do this was to be able to calculate the output BTUs when the unit was heating. I also placed temperature and humidity data loggers around the bedroom. There were three in the master bedroom, one on top of the headboard, one on an entertainment center on the wall opposite the foot of the bed, and one on top of the MHK1. I also placed these sensor push data loggers on top of the other MHK1s located around the house, the other 2 units. This is a layout of the house in question. Master bedroom shown here on the right and the great room on the left. The master bedroom had the GS MSZGL12 and the great room a GL15. And running a heat loss calculation, which I'm sorry to say was not available for this home. At the time, when they designed it, they did not do an actual heat gain, heat loss. The GL15 area at 25 degrees needs 4,600 BTUs. The bedroom 4,600 BTUs. The bedroom 4,200 BTUs. Total of the upstairs area, 8,900, almost 9,000 BTUs. And yet I have 27,000 BTUs available. You can see that alone might cause an issue. Downstairs, there was a GL18 serving the den, dining, and kitchen area. The rest of the downstairs area was not served by the Mitsubishi system. They were still using baseboard heating for that part of the house. Calculated load for the GL area was 12,000 BTUs at 25-degree design temp for that area. This is the actual heat loss calc I ran on the space. You can see the load requirement at 25 degrees for these different zones: bedroom, media room, and kitchen den. What the actual load requirement was at 41 degrees, the lowest temperature we achieved on the first day of testing. And the amount of heat available versus what was needed. You can see how drastically oversized we are here. 282% for the bedroom, 328% for the media room, and less than 150% for the kitchen den at the time of testing. Now, this is a chart of the actual bedroom temperatures reported by the MHK1, the upper orange line. The maintenance tool in the outdoor unit reported by the blue line. And the 3 lines in the middle that pretty much converge at one temperature, those are the 3 data loggers placed around the bedroom. Those are the actual temperatures of those 3 data loggers. They never varied for the entire first night, which this screen shows a time from 10 p.m. to 8 a.m. on Tuesday. 10 p.m. Monday, 8 a.m. Tuesday. It never varied from 68 to nearly 70 degrees. Not much of a change in the bedroom at all. And that I kind of expected. What I didn't expect is what we're going to see on this next slide. Well, the 2 more slides. So the disparity here, why is there a disparity between what is shown on the thermostat and what is actually going on? This was unknown to a lot of us when it first came out, but the MHK1 did not have a way for you to show the MHK1's temperature at the MHK1 on a wall-mounted unit. You could only see the temperature of the return air. So what the homeowner was actually seeing on her thermostat on that day that she took the picture, 78, that was not the temperature in the bedroom. That was the temperature of the temp sensor being affected by the heat of the coil, which anyone who has ever designed around a multi-zone MXZ system knows that in heating, we are sending refrigerant to every indoor coil, regardless of whether it's asking for heat or not. And we can get a lot of influence on that temp sensor. This caused a lot of thermostats to actually be replaced, thinking they were bad, showing bad temperatures. Once we learned this from Mitsubishi, we were able to educate our dealers in the field. The 3 bunch lines right in the middle of this chart are the 3 sensor push data loggers. Notice how tight of a temperature they maintain. This room actually did not overheat. but it never achieved her set point of 64 degrees because of the stack effect and the fact that multi-zone units will still provide some heat through convection from the hot coil. This is actual maintenance tool data from this job at 3:12 a.m. in the morning. This is the GL bedroom. Notice the temperature of the coil, nearly 130 degrees. The LED is just as open as the LED of the downstairs unit, but the fan is not running. This unit is not calling for heat. The downstairs unit is calling for heat. But all the coils in the system are going to be hot in a multi-zone system in heat mode. This was the part that really astounded me, and I did not expect. In that entire 10 hours of operation that was recorded from Monday night until Tuesday morning, that GL12 in the bedroom did not call for heating once. It never ran in heating. The GL15 ran for a little bit. The compressor ran, you see the blue line indicates when the compressor was on, and the GL18 when it was heating. Now, the criteria for me deciding whether this thing was heating was to look at, was the compressor on, was the fan on, and was there a temperature difference on the sensors in the coil? If those three factors were met, then that unit was calling for heating. The GL12 never met that criteria. And the temp difference that I put into the formula was only 1 degree. I know, right? You're thinking it's a huge bedroom with a 12K. You guys may not think that's like, a big deal or happens very much, but in the tech support world, it happens a lot. We deal with this issue a lot. So for that first night, the den kitchen unit ran 485 minutes out of a possible total of 600 minutes. The great room, 43 minutes, and the bedroom, not at all. The heat from the downstairs den kitchen unit heated the upstairs of this house due to the stack effect. Buoyancy of heated air rising from the adding to that. This was completely unexpected. I did expect the bedroom unit to run a little bit. Didn't run at all. And when I looked at it for the entire week, okay, so I had a total of 94 hours here. The bedroom ran for 5 minutes in those 94 hours. The den kitchen, 1,548 minutes. The den kitchen unit carried most of the heat for that entire house, especially the upper floor. And on a second job that I had a chance to catalog last year with a PAA coil, this was actually earlier this year, sorry. I believe this was in March of 2023. A PAA coil on the first floor, the homeowner in this case thought his gas furnace was running all the time. Okay, let's prove it with actually taking data from the system. Well, a very similar phenomenon occurred here. You can see how many minutes the downstairs unit heated the house and how little minutes, 145 minutes out of a total of almost 9,900 minutes, or only 1.5% of the time did the upstairs unit ever call for heating. Again, in this case, the downstairs unit heated the upstairs. I didn't really need to put heat up there. But we have to, because in the summer it goes in the other direction and we have to cool it. So how can we combat this, the stack effect, and give homeowners a little more comfort? We have to understand that most of the heat upstairs is going to come from downstairs, or the heating need is going to be satisfied by the heat coming from downstairs. We can't stop the stack effect without hermetically sealing off the floors between the two levels. You may instead consider the option of installing separate systems between the levels. It will eliminate the constant refrigerant flow to unused indoor units, like in the MXZ systems, and it will provide a means for cooling the upper level when the lower level does not require it. And that's about what I have to say about this. I think the data that I collected on these two jobs is astounding in how little upstairs units actually heat. And I think I've done 2 out of 2, batting 100% here. I expect that this is probably happening in the majority of every design we ever do. Yes, it's the same with branch box systems in heat mode. Refrigerant flows to every head. It's the same in our city multi-units that use Y series. Every head gets heat in heat mode. Is a solution to have 2 separate systems for each level. If I was designing it, I would give the option to the homeowner. Yes, will it cost more money? Possibly. To have 2 outdoor units versus 1. You could still do multi-zones. You could have multiple zones on the level just coming from different outdoor units. I think it's a better solution, and you can combat the stack effect by having the upstairs unit have the option to actually run in cooling if the space gets too warm. And as long as you give them the option and let them choose, if you can educate them to the effects of this, everyone who has a 2-story house already knows it's hotter upstairs. You live it every day. My own house, probably 5-degree difference between my den on the lower level and my bedrooms on the upper level. Can't stop that. If they choose to go with the cheaper option, at least that's on them. If they don't like the outcome, at least that's on them. But at least offer the option to them. Anyone have any verbal questions?
I have a question.
Oh, thanks, Nate. Yes.
This is John of Bellingham Indoor Air in Bellingham.
Hi, John.
Hey, I'm wondering if Mitsubishi might be ultimately headed towards having some kind of a VRV offering for homes.
I'm going to say no, simply because the amount of effort, engineering, and money that would have to go into that design and the cost of it would make it prohibitive for most homeowners. The ones that have a large enough house where we're just putting 2 systems in isn't enough, are already using our VRF systems. We have a lot of our R2 simultaneous heating and cooling commercial equipment in residential applications on houses that it can fit in. But doing it residentially, I don't see that ever coming.
Thank you.
Well, smaller capacity indoor units for downstairs help to make it more comfortable upstairs. Now I'm dealing mainly in my territory of Western Washington, where the cooling load in the summer is typically about 50% of what we need BTU wise for heating in the winter. If you live on the eastern side in the high desert area, it's going to be a lot warmer, and probably your heating and cooling loads get a little closer together. On the western side that I deal with the most, one of the biggest problems I see is that people just don't do heat loss calculations. In fact, due to the stack effect, if I do a heat loss calc for a multi-level house, I actually do 2. Because I do one for upstairs with no infiltration, because there won't be any infiltration. And if you just do one for the entire house, you're putting a blanket infiltration for both levels. An economizer upstairs to help battle some of that extra heat. Well, you need the unit to actually call for cooling to use an economizer. And I don't see that happening in a system that's just one system in the house. Can't have one calling for cooling and one calling for heating. But I think you could cool upstairs with outside air. That could be done. And I'm sure you could design even an ERV or something around that. But what you're actually going to end up doing there is having more outside air come into the house. Anyone that wants to experiment with something like that, let me know, because I'd love to data log it. Any more questions?
I do
I have.
have.
Go ahead.
I was going to say I have a project that we just recently installed, and I'm probably having this issue where I have two larger heads. I came in a little bit late, so I missed a little bit. I had an issue at my house, and two larger heads heating the majority of the house, and then we put a separate head in the master bedroom, and the master bedroom, sure enough, is overheating. MHK2. I'm not sure if this is kind of appropriate for this conversation, but MHK2 to help control that small head in the bedroom to shut the fan off for overheating the area.
Depends on your type of unit. Is it ductless?
Ductless one way? Yeah.
In order to stop the fan, you have to cut a resistor off the control board. The function settings that you would make on ducted units don't exist in any of our indoor units that come with a handheld remote as default control. The floor mount, the one-way ceiling cassette, or the wall mount units. None of those 1 through 28 functions apply to those units. And there's only a few functions you can do by cutting a resistor on the board.
Which will be, that'll stop the fan and allow the MHK2 to read temperature and cycle the fan on and off.
One of the things you can do is have the MHK2 show you the temperature of the MHK2. That will apply in the MHK2.
Yes, exactly.
It didn't apply in the MHK1.
Yeah. So now we can sense at the MHK2 and try to turn the fan on and off based on temperature, so it's not sitting there overheating.
Well, you can't turn the fan off without doing the resistor. And it will help with some of the overheating. But you're still going to have a hot coil. You're still going to have convective heating. And I've tried to do measurements and study on how much convective heat that is. And in this first house that I data logged 2 years ago, and that amount of heating adding to a room is probably on the order of 300 to 500 BTUs per hour, convective heat.
Yeah.
Provided the compressor is running.
Which is probably enough to heat.
You couple people in the room and then the stack effect adding the heat from downstairs, and you could easily overheat a room.
Yeah. I've been at Mitsubishi Gas my whole career. The more I learn about it, I have more and more fear about installing these multi-head systems and doing anything with it. I'm just wondering what the intention was.
You know, we learned through time and practical experience with what we end up having. So I just gotten lately where I think a better design using multi-zones is to split the levels of the house with systems. 3 heads downstairs, 3 heads upstairs if the house can support it. But at least you have the ability upstairs during most of the winter to not have that extra heat flow to those coils, because that unit won't be running much.
Yeah. Well, I'm seeing it with the bedrooms a lot because people like their bedrooms cooler than the living space. So even with the top floor situation, that's where we happen to have a bedroom in the main living room.
Right.
I think it's a type of use is going to be, or desired set points in those rooms is going to be a more refined conversation to help drill down where to match all those units.
Oh, I've heard people say, oh, well, if you want the bedroom cooler, just open the window, right? Well, that
Mhm.
exaggerates the stack effect in the movement of heated air from downstairs upstairs. So you actually get more heat coming into the bedroom so it can go out the window. It doesn't make cool air come in the window, but it makes a lot more colder air come in downstairs. The best way to combat that is a system that could actually cool to remove the heat.
Yeah. I'm in the Pacific Northwest here too. Yeah, it'd be wild to be having that AC come on to combat the stack effect on the top floor bedroom. Yeah, it just gets us into all kinds of weird corners.
I think at least, again, like I said before, offer that option to the homeowner. Even if it's more money, it's a better system. They'll be happier. If they decide not to, well, at least you offered it to them. And when you can address that part, if they come back and they're not happy with how, the house actually works.
Yeah. Okay. Thank you.
You're welcome.
This is John again. I had one more question concerning the way that you are using your data logger. I am currently logging data on an old system, 13 years old, and I now wish that I was using some of these other data information points that you're getting by putting other points around the room where you can get information. And I'm wondering just how useful what I'm going to get is without those additional data points.
Well, the more points you get, the more accurate you can be with your analysis. So, especially like the amp data logger I had to put on the S1 wire. The actual wattage of that unit is so low, most amp data loggers are not going to even record it. In order to do that, I had to make a coil loop multiplier to multiply that amp reading. And because the difference between speeds is so minuscule in wattage, you need to do that or you can't tell the difference between low speed and extra low speed.
Well, I'm pretty into being a techie kind of guy, but that's a little outside of what I have time to do and learn how to do.
Right. And again, it's all so that I could calculate BTU output. If I know how fast the fan is running and the CFM levels are posted in the submittal, there's no ductwork to worry about that would reduce the airflow. So as long as it's running in medium speed or high speed, then the rated CFM is useful for calculating that. But I need to know what speed that is. I also wanted to see every time the indoor unit did what we call an overheat protection scheme. You probably have noticed in multi-zone units, if the outdoor unit's running and the particular indoor unit is not running, occasionally, though, even if the unit's off, the louvers might open up and the fan blow for a minute. The coil got too warm and the unit's trying to cool it off.
Yeah, this has confused me quite a few times.
Yeah, I've seen that on wall head units. Sometimes 15 every 20 minutes to do it. A lot of that heat's being dissipated, just the fact that it's hanging on the wall and convective air movement up because of the heat helps to cool it off. But in the one-way ceiling cassette units, because they're enclosed in an insulated box in the ceiling, I've seen those things do the overheat protection scheme every 5 minutes in some cases. And that can easily overheat a room. But maybe even more important to offer two systems in a house if that's what you're planning to use, is those one-way ceiling cassettes.
Is that strategy the overheat fan strategy affected when you cut that wire on the resistor? Like what, I'm just trying to figure out the best path short of ripping the system out or adding a second outdoor unit at this point.
Now a lot of people have done that and still were not satisfied with the result. So you have to consider that very carefully.
Yeah.
If you cut it, it's a one-way street. You're not going backwards again without replacing the board.
And they're using the MHK2 with that cut. Does that help?
Not necessarily, no. The only thing the MHK2 helps you with is showing a more accurate reading of the room temperature, not being influenced by the heat from the coil. That's the only advantage you really gain there.
Oh, okay. So I was just thinking it's positively shutting off the fan and different or with more accuracy. But
Still going to have that hot coil.
and that coil protection will come on even with the resistor cut, or is that not happening anymore? Are we risking
Yes.
damaging the equipment?
That is still going to happen. The
So
only
it
way
sounds
you
like
can stop that from happening is turn the unit to off. If it's in the off mode, it won't do that.
Gotcha.
But the unit's going to suffer because it's going to protect itself differently. We'll start trying to get the compressor to slow down.
If the unit's off.
But there's a limit to how far we can slow down. So it can create other issues that you're going to have to deal with.
Yeah. That brings up, these outdoor units, the turn down on them has gotten a lot higher than the older units. Imagining that's some efficiency wrangling, but yeah, it's become really tricky. That
a lot of the Portage units do not dial down as far as you think they do. A lot of contractors make the mistake of looking at the turn down rate on the indoor unit. But once you pile that onto a multi-zone unit, you don't get that turn down rate. Most of the units turn down only to 50%.
Yeah.
And it's worse in the 3Cs, the 24 and the 3C30, because they're actually got the same compressor as the 4C36. So where the 4C36 can turn down to 50%, the other ones can't.
Which is really the vast majority of houses for a multi-head system will be 1,000, 1,200 square feet, 3-4 heads would be ideal. And these things are they scare me. I don't want to put them in at all. They're just overproductive and
Yes. So got to get a little more creative and educate ourselves into what's really driving this and these complaints that we have learned. Most of it's due to oversizing, drastically oversized, not even doing heat loss calcs. Not every two houses are the same. Some houses are extremely tight and some are extremely leaky.
Well, a lot of the oversizing, for us, we do load calcs on everything that's more related to connection with heads and the size of the equipment. Like we have regular 22, 23, 24,000 PTU loads where you want to put in 3-4 heads. And you don't, there's not really a viable option. I guess a bunch of 2C20s everywhere, but it just gets tricky. There's nothing that mates up with our load counts. So oftentimes, actually the 5C24 sometimes gets us out of a jam because it does have a lower turn down, puts out more heat, has more connectivity. But yeah, it's frustrating to have to play a bunch of games to get these houses heated correctly. And from a competitive standpoint, I don't know, either other contractors aren't saying it, or I've seen some products that do have a better turn down or have more connectivity on smaller units that kind of help alleviate some of these issues. Do they have one last question? I don't want to dominate the conversation. I did talk to Jeff Armstrong, and he had mentioned that when you're sizing heads to only go up one size, have only one size difference between the heads, not big heads and small heads together. I don't know if you covered that earlier, but is that something that you're aware of?
Well, here's what I've learned in 9 years of doing this and spending a lot of time looking at the data. You can get away with oversizing a one-to-one system up to 50% oversized. So 100, so if you need 12K and 18K is not going to generally cause you problems. But on multi-zones, you can't go over 25% or you're going to have problems. You're going to have complaints, generate complaints. There's a lot less tolerance for a multi-zone with oversizing, simply because it can't dial down that far.
Yeah.
And now in the new 2023 version of ACCA's Manual S for equipment selection, they say that you can size your unit on its turn down ratio as 80% of the total load, which in a multi-zone unit is going to allow you basically to oversize it to 120% or 125%, no more. So if you get a unit that's 200% sized for the actual load, expect complaints that cannot be solved. Everyone is afraid of undersizing it. In many cases, forgetting all the other loads in the house are heating the house. Our heat loss calc that we do is based on nobody being in the house and everything being turned off in the house.
I
And
see
when
a
you
lot of
throw it,
times. I'm sorry. I was going to say a lot of times we don't have the option to undersize. That's a bit of that goes a suggestion for the suggestion box to Mitsubishi is smaller
and that's
systems.
being
Maybe we're
driven
just
by the need for the number of heads. I need to have this many heads in the house, and it leads to oversizing because the house can't really support that many heads in the house for the size, the amount of heat they're going to put out. It might be better to do one ducted system if that's possible.
yeah. Well, thank you for answering all the questions. Yep.
Yes, and keep in mind, you don't need to get every job. If the homeowner demands a unit in every room, maybe you don't want that job. Or you have to be able to articulate to the homeowner why that's a bad idea.
Yeah. Well, Mitsubishi's advertising 8 heads on one unit in some areas, so we it's like we have to overcome some of the messaging that these people are getting. I don't blame them.
Well, if you went into our Kirkland branch, I don't know if it's still there, but it was there 2 years ago. In our Kirkland branch was a poster right inside the door of a Mitsubishi MXZ advertisement, and it showed a 2-level house with a temperature upstairs of 67 and a downstairs temperature of 72. That's physically impossible,
Mm-hmm.
and you cannot find that poster online anymore. Now the best you can find is a poster that shows temperatures pretty much the same in the house on a multi-zone unit, but due to the stack effect, buoyancy of warm heated air, it's always going to be warmer upstairs. It's impossible to have a room upstairs colder than the room downstairs, unless you seal the door off in the room and then open the window. That might be possible. That led to a lot of complaints from homeowners because they saw that poster or they saw this video. And I like this one, individual zone comfort. That does not mean it simultaneously heats and cools. We just need to get better at designing these systems to not exaggerate the heating of the upstairs level. So we generally don't get overheating complaints on single level homes unless the units are drastically oversized.
So in general, how big of a room have you seen? Let's just say on a hyperheat system, pick a GS or an FS wall mount. I don't care. how big of a room have you seen? You know, I know there's obviously varied factors, but how big of a room have you seen a 6K satisfy in an upstairs room, let's just say?
You know, that's a good question and a tough one for me to answer because the ones that work, I never go out to see.
Oh,
I only
absolutely.
get involved when they don't work. So one that's really working well,
Yeah.
um,
How far are we away from that 4K?
well, this is lately, you know, since the smart multis come out, everybody's in love with some of the smart multi stuff. You know, it's always been both a PUMI and an MXZ unit. If you use a city multi setup using city multi indoor units, we have a wall K that is a 4K. We have a ceiling that's a 4-way that's a 5K. We have a
But the
lot smaller unit options going with city multi units.
but then we've got to contend with those expansion valves being at the indoor units and making noise, and I can only see what that would create from. But maybe it
Those,
wouldn't.
those still don't really cover. They're still too big for small, you know, for bedrooms, not even small bedrooms, average bedrooms. But that's still a high, I don't know. It's guessing that a high load compared to what we see 2000 CF, 2000 B2s in these rooms, 3000 B2s in these rooms.
Right. You know, sometimes it would be better if you could do a small ducted unit like the SEZ and spread it over 3 bedrooms. A 9K spread across 3 bedrooms, 3K in one room, 2K in one, 4K in another, splitting the airflow properly is a better option than putting 3 wall heads in those 3 rooms.
But we still got to maintain 15 feet of duct on those, right?
Maintain 15 feet.
You said it can't do more than 15 lineal feet on those SEZ units, or is that not true anymore? Is there low
It's not
static?
technically true, provided you size the ductwork properly. The
We
unfortunate thing about the SEZ is whatever you used to do on the return air, you're gonna have to double.
Well, absolutely. Um, yeah, I just put a PEAD in that same in a knee attic situation. Just maybe it was overkill, but it was a 9K for 2 bedrooms upstairs, and it's working great. So,
Better than putting 2 6Ks. You at least have
oh,
less heat. And the PEAD, if you can fit it, it's bigger than the SEZ, can do 3 times the static pressure. Ductwork is usually a problem on those units.
what's the performance like? Because I've got a situation on a project I'm coming up in where they put this low boil oil furnace in this crazy. No, there's really no height above it, and I don't know if I could fit an air handler horizontal in there, but I might be able to fit a PEAD like 3 ton in there. Do those perform as well as like a 36 air handler, as far as you've seen, as far as airflow and performance? Obviously, the ductwork being sized properly, but I'm just talking about.
Sure, that's the key word. If the ductwork is sized properly, yes, it works fine.
Okay, cool. Yeah, then it's just interchangeable. I just wanted to check because I think the biggest one I've ever put in is like an 18. So I never went any bigger than that.
Oh, I like, you know, people thinking outside the box, trying to be creative with some of these solutions rather than trying to, you know, fit a basketball in somebody's shoe. This doesn't work. We're tearing up the shoe.
Well, and I just ran into one on a cassette, and I'm sure you've ran into this several times, but when you put those in lath and plaster ceilings, obviously there's all the problems of cutting the hole, but those ceilings aren't level. So you hang the unit level and you don't, how do you get that grill to sit flush without putting a trim kit on there or something? And that's what we've come up with. And I didn't know if you've had any suggestions on that. I mean, we've got the ceiling, of course, is about, a quarter inch out of level in the short side of it, not in the long way, but it's, in the short way and the depth of the grill. So on the back side, it's hanging down like, a quarter inch and then flush to the ceiling. And we're going to put some tapered trim in there, but you can't hang the unit not level. So,
Oh,
right.
you nailed it. Trim kit.
And so like
It's
we're going to taper like some MDF or something and try to make it look nice, but not everybody's a carpenter or whatever, and it's like there should be some kind of trim kit for those ceilings because you know not to mention there's 2x4 framing and nothing to hang off of the rafters, so we have to sister 2x12s and then make a bracket to hang it. But I mean, it's all that stuff you learn when you're doing it. But the trim kit would be nice for those, or something to make up for that. But maybe lath and plaster is a small percentage of their business, so they probably don't care.
Well, it is a small percentage.
So we'll do some carpentry.
Yeah, I've had contractors, lath and plaster walls. If you don't put my unit level or flat, then you put stresses on points in the unit that shouldn't have stresses, and things wear out faster, like wall head units, the bearings in the blower. They'll wear out faster if they're twisted when you mount them to the wall. But I have some contractors who will mount a sheet of plywood and shim it, and then around the plywood, they will put trim. Tapered to cover all the holes. It looks pretty cool. Looks nice. They do a good job with it, but at least they get the unit flat.
Are you going to be doing your duct design class again soon? Or is that, I think I signed up for it, but I just wanted to make sure. I'll check today.
We just did one, what, 2 weeks ago?
2 weeks ago. Okay.
There's some that it will be announced. I've got, people requesting it in Vancouver, up north, Burlington, Bellingham area. So I just got to fit it in my calendar, which is, I'm sorry to say, pretty jammed up right now.
Well, it's good to be wanted.
I guess.
It's a blessing and a curse, my friend.
Right. Well, I'm glad you attended, Matt.
Oh, thank you. Yeah, no, I was interested about this class because I got one right now. It was just that one I was talking to you about, and it was a house where I had a 30K air handler ducted to serve the basement and main level. And then I had a 9K cassette in each big bedroom upstairs. And I'm glad that I did that now. Maybe I could have even done, the KYs in there and been fine. But when I put it into the DSB, it had different outputs than obviously what are on the submittals. So, a little bit lower. Does that seem to be more accurate than just going off of like what the maximum capacity is at each temperature rating? It's more accurate to DSB.
Well, the DSB is great for a lot of things, but sometimes the numbers aren't correct.
I see.
You really should go to the engineering manual that would show you the chart for the capacity output at different temperatures. I just had one last week where the numbers didn't even come close to what the engineering manual. That's going to trump the DSB. You got to bring it to their attention, and then they have to, go in and see why that was what it was. But that's why DSB is constantly getting updated.
Right.
And every month or so, it's doing an update because they find something and they fix it.
Well, it's never finished.
No, it never will. And just when they get it perfect, everything's going to change and they'll have to do it all over again.
That's right. Just like Kumo.
Well, we have some 3-phase smart multis coming out. They go up to 10 tons.
That's what I heard from the dealer meeting. Yeah, I'm interested to see that. Well, we'll see if
12 heads on a smart multi with 3 branch boxes. That's going to be my nightmare.
You're going to be going to so many houses where they have 12 head systems in, and it's going to be like a 3,000 square foot house with 10 tons. And you're going to be like, you're just going to be scratching your head. That's
I've worn out saying because you can doesn't mean you should.
Right. It can be done.
If I had $1 for every time I've told that to someone, I could buy Elon Musk out.
Right. Well, the majority's not always right. So, you betcha. All right, man. Well, have a good day. Thanks for the class. Appreciate
You
it.
too, Matt. Anyone else? If not, we'll conclude and let you go make some money.